So in this video, we will solve a problem from calculus by Munem Foulis. So the question is, answer true or false using suitable rules for inequalities to justify the true statements, and give examples to show that the false statements are really false. And we have a number of statements that we are asked to consider. In this, we will be using the following properties. The first one is called the rule of trichotomy, that either A is less than B, A is equal to B, or A is greater than B. The second rule is that of what they call transitivity, where if B is greater than A and C is greater than B, then therefore C must also be greater than A. Next rule is that if A is less than B, then adding a constant to both sides, or adding the same thing to both sides, does not change the inequality such that A plus C is still less than B plus C. The next rule is the converse of the previous, and it probably really doesn't need to be stated as a separate rule, in that it is just subtraction instead of addition. And then we have multiplication and division, which are have this particular issue with the multiplicand being positive or negative. And in the case of positive, then it's simply A times C is less than B times C if A is less than B. And similarly for division. However, if you have a negative multiplicand, then the sign in the inequality has to be reversed. So the first part of the question is, x is a positive number, is equal to x is greater than 0. What we can prove here is that by multiplying both sides by 5, we get 5x is greater than 0. And therefore 5x is a positive number, and the statement is true. The second part of the question, we're going to restate this inequalities as x is less than 3 and 3 is less than y. And then by property 2, which is transitivity, we can conclude that x is less than y, and the statement is true. In the third part, the inequality x is less than or equal to y is multiplied by a negative number, and therefore the inequality sign has to be reversed according to property 7. And therefore the statement that is given is in fact false. Counterexample is, for example, x equal to 1 and y equal to 2, and if you work it out, you find that it ends up giving the wrong answer, that negative 5 is greater than negative 10. So for subsection D, we are given that x squared is less than or equal to 9. If we subtract 9 from both sides and by invoking property 3, we get x squared minus 9 is less than 0. We can factor that as a difference of squares to x minus 3 times x plus 3. And we can see that the equality holds when x is either 3 or negative 3. For the inequality to hold, negative 3 or x minus 3 and x plus 3 have to have opposite signs, so we have to consider two cases. The first case being that x minus 3 is greater than 0 and x plus 3 is less than 0, and then in the second case the signs are opposite. In the first case, x has to be both bigger than 3 and less than negative 3, which is actually impossible to happen. And in the second case, the x has to be less than 3 and greater than 3, which limits it to the interval negative 3 to 3 inclusive, and therefore the statement x is less than 3 is true. And then the final part, to show that if x is greater than or equal to 2 and y is greater than or equal to x, then x is greater than or equal to 0, we will use property 2 repeatedly, which is transitivity. Since x is greater than y and x is greater than or equal to 2, then y is greater than 2.